This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your host, Radio Joe Hughes, and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. We've got a great show for you today. We've got Nate, the House Whisperer Adams, joining us for the hour. This is show number 522. Nate is going to be talking a little bit today about building science, indoor air quality, and insulation, a topic near and dear to my heart since I'm remodeling a couple places right now. I'm looking forward to the discussion. Before we get started, let's thank our sponsors.
IAQ Radio Platinum sponsor is John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com.
I also want to thank our gold sponsors, Particles Plus, Healthy Indoors Magazine, Gray Wolf Sensing Solutions, and AEML Inc. Laboratory. And of course, our association sponsors, the Indoor Air Quality Association and the Restoration Industry Association.
And now you can win a cool prize. It's time for the IAQ Radio trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio trivia question.
Hello, everybody. Congratulations go out to Thomas Wesley Barnes III in Greenville, South Carolina, for identifying that timekeeping in Nepal is based upon Mount Everest. The IQ Radio trivia question for today, Friday, November 2, 2018, has been sponsored by Ideas, the solution chemistry company, creating unique solutions to odor removal, surface cleaning, and decontamination problems. Here is today's trivia question. Where was the world's first electronic power plant located? Back to you, Joe.
Thanks, Cliff. Today we've got Nate Adams out of Cleveland, Ohio. The company is Energy Smart. They started out as an insulation contractor, Nate did, for existing homes, and has evolved into doing comprehensive home performance retrofits. Projects are anywhere between a simple attic insulation and a deep energy retrofit. Nate's got an interesting history, started in the insulation business and then got into the actually sales of insulations to start with, and then got into putting insulation into homes, and then got a little insight and decided to do whole home performance. And he's got a great book as well. I've got a copy of it right here. The Home Comfort Book. Actually, it's signed by Nate too, so I like that part. You know, Nate Adams, welcome to the show.
Thanks for having me, guys. Great to be back.
Nate, part 3. For those that weren't here for part 1 and part 2, let's do a real quick kind of a review of things. John, can you put up those slides for me? Let's start with the first one here. Go to number 2, if you would. There we go. That's the book, number 3. And so we started with a little on home comfort, HVAC 101, 102, insulation types, bath fans, and lighting are the last 2 chapters. Nate, anything you'd like to do to kind of set the stage here?
We're actually going to do that as we get started here. So, but it is important to note that insulation is actually not the most important piece of the puzzle. Air sealing is, so we'll be talking a lot about that.
All right. Next, John. There's the insulation bunch. We'll talk a little bit about the different types of insulation, but let's go one more. Talk about a little about the pier analogy, Nate.
Sure. So explaining the difference between insulation and air sealing, I always kind of struggled with it. And this is what I found to be the easiest way to understand. So imagine I put you out on a pier. It's the middle of winter, say it's 20 or 30 degrees outside. There's a howling wind coming by, and all you're wearing are jeans and a t-shirt. You're frozen. So next slide. And then I cruelly give you the option between either a sweater or a windbreaker. You have to pick one, only one. Which one do you want, Joe?
I want the windbreaker.
Darn Skippy, because it'll at least keep the wind from blowing right through you. You'll still be cold, but if you have a sweater, the sweater's just going to let the air go right through it, and it's not going to insulate. Ideally, what you want is both, but the air sealing is actually more important than the insulation. But ideally, you want both.
Absolutely. So you got to get out there and find all the holes, preferably by doing a blower door test, and then seal up those holes first. And as I think most listeners understand, some insulation can be an air sealer, but we'll talk about the differences here in a minute. Let's go to the next one, John. Nate, what do you got? Why do we have this one in here?
This is the physics behind making houses work well. So if you want a house to be comfortable, you want it to be healthy, you don't want it to have moisture problems and fail early, and you want it to be efficient, you have to get control over these three things. Doesn't have to be perfect control, but needs to be decent control. So if you can control airflow, heat flow, and moisture flow, on one hand, in and out of the house, which is what insulation and air sealing is about, and on the other hand, inside the house, which is an HVAC job, your life is going to be much more comfortable, much more pleasant. And of these, the air rules supreme, particularly when you're talking leakage in a house, because heat and moisture travel on air. So if you can stop air movement, you can generally reduce your heat and moisture losses.
Okay. Do not insulate until you have air sealed. Full stop, or your results will suck. Air sealing trumps everything. Next. All right. So we talked a little bit about some of the problems, but I don't think you mentioned all of these. Air sealing can help with these four topics.
Yep. So these are just a few, but the root causes of these are typically air sealing. So if you have very uneven temperatures in your house, like your second floor, in the summertime, you walk up the stairs and you get hit with a wave of heat, that's probably an air sealing issue first. It could also be HVAC, but you have to check the air sealing first. If you have mold issues, you probably have too much air leaking in from outside with high dew point, you're not dehumidifying well enough, or if the house is too leaky, there's too much moisture from outside coming in, and you can't dehumidify it fast enough. So I'm sure everybody has seen a dehumidifier in a basement running its brains out. When you seal up a basement, oftentimes the dehumidifiers largely stop running. The next one is rodents and pests. They come in through holes. And when you air seal, you reduce how many holes they can come through. And the last one, ice damming, that's more of a northern problem. You really need to live near a big lake. But Cleveland is by a big lake, Lake Erie. So we get really heavy snowstorms, and then it's cold for a month or two at a time. And that leads to icicles hanging off the gutters of the house, which is a problem because that can lead to all kinds of weird moisture problems inside the house. It'll actually drop ceilings inside by leaking water inside. There's all sorts of bad things that happen from ice damming. And the root cause of that is usually too much air leaking from the house into the attic and then melting the snow on the roof.
All right, next one up. All right, there's the one I asked you to put in here, Nate, but it's a little tough to see. So, and obviously we also have people listening on the podcast. Talk a little bit about the R value spectrum and what R value is first, and then where different types of insulation fall in on that spectrum.
Sure. So R value is a measure of resistance to heat transfer. So the higher the R value you have, the less heat will transfer through. A lot of people think of this as being super important to get to the really high levels. It's not, as we'll see in the next slide. But to give you an idea, an uninsulated wall typically performs at about an R5 or an R6. An insulated wall, which will have R13 fiberglass or R13 cellulose in it, if you're talking a 2x4 wall in existing homes, that's going to be about an R13. When you get to attic insulation, usually you're going to start with about an R30 if you're talking houses 1980 and afterwards. R30 was code for a long, long time in most of the country. And then as you start getting deeper into it, Department of Energy recommendations for most climates are R49 up to R60. But that may not be quite as important as you think. And the other thing that's really important to note is these R values are only achieved when they are in an air-sealed cavity. If there's the ability of air to go through the insulation, its R value is likely to be substantially diminished.
Okay. Again, going back to that air sealing. If we don't have the air sealing, you can put all the insulation in the world, at least certain types, and it's not going to help a whole lot.
Correct. And we'll be talking different types.
And that's actually where we go here. And to some degree, the diminishing returns of more insulation. Now, this, as I understand it, is if you have a well air sealed cavity.
Correct. So,
all right.
For instance, fiberglass bats, all the tests that are done on them assume a sealed cavity. So it has to be a sealed box. All 6 sides are sealed. In that case, fiberglass bats perform really well. We've used them in several new house projects that we've been on, and the results have been excellent. But if you just put fiberglass insulation in a leaky wall of an old house, the results are typically terrible. In fact, I have that struggle in my own house. Somebody did that in my house, but it's really difficult to fix. But this chart, what it's talking about, I borrowed this from Allison Bales at Energy Vanguard, which is a really good blog to check out. If you're into building science, please go read his stuff. He's a very good explainer. The articles aren't super long, and the comments are usually really interesting. But he put this chart out a couple years ago showing how much heat flow is reduced by going to certain R values. So this is made for Atlanta, Georgia, which is not a super cold climate. They're pretty mixed between heating and cooling, but the principle applies wherever you live. So basically, when you go from no insulation to an R6, you've already reduced about 80% of the heat transfer. So very, very minimal insulation. We're talking a couple inches of fiberglass, an inch of closed cell foam. It's not a great deal. And what we've found in our projects is when we use spray foam, which we'll talk about later, oftentimes we're only using 3.5 inches of spray foam, which is about an R20, an R25. And that delivers really remarkable results from both a comfort and an efficiency perspective. So you may think of, oh boy, we can do R100. We're just going to keep filling this attic full of cellulose. At some point, it doesn't matter. Really, beyond about R20, you want to look for air sealing opportunities first.
Okay, next. Here's the 5 priorities of home performance. I love it. The first 3 are pretty much the same, huh?
Yep, air seal, air seal, air seal. Those are the first 3. I had a lot of trouble getting through client heads just how important air sealing was. So I made it the first 3. And then you worry about insulation. That's number 4. And then the right HVAC is the 5th priority.
Okay, next. So let's talk about, if you talk about air sealing, then you have to know a little bit about a blower door and the blower door reading and what they mean. Why don't you go over this for listeners?
Sure. So a blower door is a big fan that you put in the door of your house. So it's this big red shroud that has about a 2-foot round hole in it that a big fan goes into. And this slide is one that still cracks me up. I lost a bet with my marketing professor that I couldn't get to 100 likes on my Facebook page. And the next day I woke up to 101 likes. I had to go rent that suit. But you get an idea of what a blower door looks from that. What the easiest way to think about how much a house leaks is to compare its blower door reading, the raw reading, which is in cubic feet per minute at 50 pascals, which is really dorky and doesn't really matter. I compare the reading to the square footage. So say you have a 2,000 square foot house and you have a 2,000 blower door. That is a 1-to-1. And that's pretty good. That's like a B, B minus, maybe a C plus. Oftentimes a house at that level is controllable. So if you have comfort issues, the solution is likely to be more HVAC focused than it is insulation and air sealing focused. But as you go to older houses, you're going to get to a 2-to-1. So that same 2,000 square foot house would have a 4,000 blower door or a 6,000 blower door if you're talking a teens or 20s house. And on the flip side, when you get to new homes, like my in-laws' house is a good example of this. Their house is an 1,800 square foot ranch. Their blower door is just under 1,000. So they are about a 0.5-to-1 leakage ratio, and that's considered a very tight house. At that point, you have to start paying attention to bringing in fresh air and watching the air quality more closely. So new homes are going to be typically somewhere between 0-to-1 and 0.5-to-1 ratio.
And an older home is going to be more like 2-to-1.
2-to-1, 3-to-1, and I've seen a few 4-to-1s.
Wow.
They make the sunken Titanic look watertight.
All right, let's go to the next one. Tracking the reductions.
So this is a bunch of our projects. And actually, I want to thank you, Joe. You're the one that made me do this. You didn't mean to, but you did. I hadn't gone through and actually charted the reductions because I wanted to see how they were. And we had one house that was just crazy. It wasn't really fair. That's the insane one. It was about a 97% reduction. But I started with a house that had no walls, no ceiling, no nothing. And it was 120 years old. So not really fair. But you can see most of our reductions are upwards of 50%. Well, I guess not quite most, but close. Our average is a 47.2% reduction in air leakage. This is a very, very, very important thing to track, which is why I wanted to put this in here.
Okay, next. Oh,
one back.
We go past one there.
Sure.
Yep, here we go.
So this is a different way to look at it. So the percentage reductions are good, but if you're going to talk percentage reductions, you need to know where you started from. If you start with a tight house and you knock its leakage down by 50%, I am much more impressed than if you take that leak yield barn and knock it down by 50%. So these are the same projects charted by how many points on the blower door we got it down, or CFM 50. And our average is about 2,800 that we knock out of a house. And remember, for reference, my in-laws' house is just under 1,000. It's a 995. So we are on average taking 3 times the total leakage of my in-laws' house out of the homes that we're working on.
And I'm assuming a lot of these are older homes that, really need that they might come in at 2-to-1 to start with.
A number of them, but well, you can kind of see, you can tell by the reductions here. If you're getting a 5,000 point reduction out of a house, it started out leaky. But
Yep.
About 20% of our houses were built since 1980, which in my mind are basically new because the construction methods haven't changed drastically since then. Every decade before that, I can look at a house, look at a couple of details and say this was built in the 40s or the 50s and the 60s and the 70s. You get to the 80s and it's much more difficult to tell when it was built.
Okay, let's get into the types of insulation here now. I believe that's next. So we've got insulation types. We're focusing for listeners on retrofit, not new homes, although all the same principles apply whether it's new or a retrofit. But let's go to the first one. Here we go. Cellulose or loose blown. Very common today. You get these bags of cellulose. You pull that out. You rent a machine. You put that in your attic. Talk to us a little bit about that.
So yeah, it's actually, I want to back up one quick step there. Is that when we're talking about retrofit, there's a few things that I really care about. I want to have some idea of how effective the material is. I want it to be relatively available, and I want it to be able to be installed easily and well. So you want good results without a ton of training. Because frankly, you're not going to get a ton of training in the insulation contracting field. You're just not. You find some people that have been out there for 5 years, but for the most part, your installers are going to be doing it for a year or less. So if you aren't careful about your materials choice, you may cut off your nose to spite your face.
Okay.
It's important not to do that. So cellulose is one of my favorite materials. And we'll first talk about using it in attics. So if you're going to use it in an attic, this is actually a good DIY task after you air seal. Do not blow until you air seal, or you will not be able to find those air leaks anymore. But one thing that's nice about cellulose is it's much more dense than fiberglass, so it is less prone to convective looping. And the easiest way to think about convective looping is thinking about a single pane window. So, Joe, do you have any single panes left in your house?
I do not, thank goodness.
Good. Well, maybe at this rental that you're working on, right?
Oh, well, actually, no, they've all been replaced too. We got double pane all over. My screen door is my storm door is about the only single pane I have.
All right. Well, so we're going to have to talk about your storm door. So if you just leave your door open and the storm door's there, a lot of people think that their windows are the ones that are leaking, and that's usually not what's going on. what's happening is warm air is coming across the top of the room. It's touching the cold glass. It's cooling and it's falling. And then it falls down to the floor, hits the floor, comes back into the room, and then is heated back up again by the room. And it starts doing a cycle called a convective loop. So insulation, the more dense it is, the less prone to convective looping it is.
Okay.
So between fiberglass and cellulose, my preference is cellulose. It's not a super strong preference, but that is definitely the preference in our projects. But we've seen good performance out of fiberglass as well. But in existing homes, if you are going to do it yourself, this is a very nice material to work with. You'll come out looking like a gray snowman, but it will wash off, where fiberglass is going to tend to be a bit itchier to work with, but it's also cleaner to blow.
I guess the other key point you made with me on my home, I'm going to be doing this soon, is that, it has fiberglass bats in it, 6-inch fiberglass, but most important is to pull that back to start with and air seal everything, which I think we focused on a good bit. But I guess the question then becomes, if they were stapled to the roof joists, or they're stapled from inside, would it make any sense to cut that out, or should I just go ahead and fill in over top of it?
So the only answer to detailed questions like that is it depends. But I can give you an experience that we had.
Okay.
So we did a project last year. It was a Cape Cod that was done with a hot roof, which is what that's called when you insulate the roof line. And we pulled fiberglass out that was R19, and we replaced it with spray foam, which was only an R20, R25. The second floor in the summertime used to be 10 to 15 degrees warmer than the first floor. And that's in addition to having a window unit running up there. So the air conditioning's on for the house and there's a window unit running, and it's still 10 or 15 degrees warmer. Afterwards, by playing with the dampers, we can actually run the second floor a little bit cooler than we can the first, and no more window unit. And all we did was switch the insulation from being fiberglass to spray foam.
But the spray foam was also an air sealer.
Exactly. Yes.
And that's the key.
Yep. So in doing hot roofs, you have to be pretty careful how you do them. They can be done several different ways successfully, but by far the simplest way is spray foam.
Okay. All right. Let's go to the next one. Oh, there we go. All right. Now, we were talking about cellulose, and this is a topic near and dear to my heart. And I think a lot of people with, older homes, or they're helping people with older homes, they're trying to get a little better insulation in their walls. They are going to do some air sealing to start with, but then they may want to use the cellulose dense pack. Can you talk a little bit about what that is, and if you're having someone do that for you, what to watch for?
That was a bunch of questions all at the same time, Joe.
Well, what is the cellulose dense pack?
So we'll start with what a dense pack is. The issue if you don't dense pack is that the insulation in the wall is going to settle. So if you don't put it in there super tightly, just by walking around the house, you're going to vibrate the house. Storms are going to vibrate the house, and you're going to end up with an 8 to 12-inch gap at the top of the wall if it's not insulated. Okay. So dense packing, the easiest way to describe it is 3 pounds of crap in a 2-pound box. I think anyone who lives in the South knows that saying. It's a colloquialism. And so what you're doing is you are pumping cellulose into a wall beyond its natural density. You're putting it in there tighter than you want, or than it wants to go. Doing that well is 100% in the hands of the installer. So you need to have somebody who's good at doing it and patient, and it involves a lot of working the hose up and down inside the wall. So it's a little bit of a finicky thing, but again, if you have a blower door there and it's in and you're testing throughout the day, you can get an idea of how much you're knocking it down. And actually, in the case of this project that this is a picture of, we were not doing very well on air sealing. And this is the only project that I substantially missed my air sealing target on. On Energy Smart Ohio, this is the 1900 House of the Future. So we ended up letting the crew know, hey, we'll give you guys $50 extra each if you hit this target. And they missed by a few points, but they were close enough. But man, all of a sudden they were spending more time blowing it in the walls, and they were going around with caulk guns with anything that wasn't nailed down. They were caulking it down. Like, it was pretty remarkable watching them run around to do that. So in dense packing, it's all up to the installer, how well trained he is, how much he cares. So this is something to consider bonusing guys on blower door numbers.
So if I'm watching the guy do this dense packing, I mean, should I see him, how long should I expect him to spend per cavity? Should he be drilling 1 hole, 2 holes, 3 holes, 4 holes? Give me some tips on that, Nate.
Oh, that's a great idea. So really all you need is 1 hole, but you do it with a tube method, which is what you can see in this photo here. So there's about a 2-inch diameter tube going into the wall. And what you do is you stick the tube in, you insert it to the top of the cavity, you let it touch the top plate of the wall, and then you pull it back a couple inches and you let it blow full. And it will dense pack around the tube, say about a foot around the tube, something like that. Then you pull it back a little bit, 6 inches, 8 inches, something like that, shove it back in to the same place, and then pull it out again, and you open up a little cavity, and then it will fill that cavity up. The whole time it's filling the wall from top to bottom, and you just keep working the hose back and forth as you're filling the wall, and by the time you're done, it will be very tightly packed. Takes 1 to 3 minutes a cavity, depends on the cavity.
Now, in a lot of older homes, you have fire stops in these wall cavities. So there might be a 2x4, 1/3 of the way up the wall going across. In that case, what does the guy have to do? Does he have to put 2 holes?
Yep, that's another hole. So I hate those jobs. I've had them. You end up with 3 holes up and down. You have to take off a bunch of siding. That's not fun, but that's what has to be done.
Is it easier to do it from outside or inside if you have that option?
It depends.
Okay.
Going from the inside is far easier from an installation perspective, but it's extremely disruptive. So now you're going to have to repaint the outside walls of the room because you just drilled a hole every 16 inches or thereabouts.
Understood.
And you're going to get a bunch of dust everywhere. So if you just bought a house and you're renovating it before you move in, do it from the inside. Otherwise, you can do it from the outside, with the exception of brick. Bricks. There's not a good dense pack option. That's where other types of insulation come into play.
Great stuff, Nate. Let's go to the next one. I think we can squeeze one more in before the break. All right, we got the fiberglass, loose or blown in. So I think all the listeners are familiar with fiberglass bats, which you roll out and they can be faced or unfaced. You could have craft facing on it, which is like a paper facing, or they can be unfaced. But you're talking here about fiberglass that is loose or blown in. Can you give listeners some pros and cons to that type of insulation?
Sure. It's mainly a preference thing. Like I was talking earlier, cellulose is more my leaning, but fiberglass works fine too. Fiberglass is going to be a little bit cleaner blowing, but it may be a little bit itchy, where cellulose is kind of filthy as you blow it, but then it washes off easily. The fiberglass tends to have a little bit more convective looping going through it, but if you run it deep, it's usually not a massive deal. If you're in a really cold climate, you might lean more towards cellulose than fiberglass. It's big differences in temperature that drive that. But a big point here, if you're considering bat insulation versus blown insulation in your attic, do blown every time, because it will go around everything. A perfect bat install is really difficult to do because you've got to walk around and work around all of the joists that are in the attic. So you're inevitably going to end up with small gaps. Those small gaps can actually hurt you quite a bit, where blown in insulation is just going to fill everything naturally.
Let's talk a little bit about indoor air quality with these types of loose fill, whether it be fiberglass or cellulose. Fiberglass is certainly an irritant. It's a particulate matter issue. The cellulose has particulate matter, but it's probably not as much of an irritant, at least in my experience. If I've got somebody blowing into my attic, what should I be watching for to make sure they're being careful with my indoor air quality. I don't want that stuff blowing around the rest of the house. I want it to stay in the attic. So can you give us a tip or two on how to make sure that it stays in the attic and doesn't get in my air in my home?
It's a good question. So it depends on season, and I don't know how much it really matters because it's such a temporary thing. But if you can pressurize the house a little bit, so again, a blower door could be useful for this. So if you have a blower door in one of the doors and you pressurize the house just a little bit and leave the attic hatch open, it's going to blow blow any air from the house into the attic, and it shouldn't allow the ventilation to come in. If it's really cold outside, if you open a window on the first floor, or you just have the door open from where the blow hose is coming into the house, that's going to end up creating a lot of stack effect. And then typically getting the dust in isn't that big of a deal.
I guess you could always put an air filtration device, you know, a portable one, or if you have a good one, you can put it in your home and run it while they're doing this.
Yes, but the more important part still comes back to air sealing.
Yes.
The blowing the insulation, that's a temporary problem. That's going to be a one-time bit of dust in the house. And so you're going to need to do one decent cleaning after an attic job, more than likely. But if you don't air seal, whenever the house goes into negative pressure, which is a lot of the year, you're going to be sucking some of that insulation into your house, and then you're going to be breathing it. And I've seen that on several houses where the filter on the HVAC is plugged with cellulose. Fiberglass is hard to tell because it's white. Cellulose is easy because it's gray.
Now, let's talk real quick before we break for the halftime here on the key areas in the attic that need air sealed before you let someone blow this stuff in. I think most people realize, you know, canned lights and the fans in your bathrooms and pipes going up for the stack for your bathroom. You know, those will all need to be well air sealed. Cables that are going up through there for, you know, your cable TV or your internet setup maybe. But I think one people don't often think about as much as they should maybe is the chimney and around the chimney and how important that is. Do you have any other tips?
So so chimneys are very important. You have to be careful how you deal with those. If it's a chimney that's going to see a lot of heat, you need to use the fire-resistant methods. So typically flashing and fire caulk is used for that. If the chimney's been decommissioned, which happens a lot on our projects, you can foam it. But the other thing that's really important that doesn't seem like it should matter that much, and the leakage usually isn't that big of a deal. You usually get 300 to 500 point reductions on the blower door, is doing the top plates. And it's particularly the exterior top plates. When you think about the roof line coming down, particularly if you're in a ranch or something that has a low pitch roof, a 412 or 612, you have very little room for insulation right at the edge. So you have a lot of heat loss that comes through the top of the wall, both from stack effect air rising through the house and just from simple convection and conduction, because there's very little insulation on top of that. So dealing with exterior top plates in particular is really important. Interior top plates matter too. If you get a blower door test, walk around your house while it's running and put your hand over the light switch plates and the outlets on interior walls on the second floor, and you're going to feel a lot of air coming through them. That's coming from the top plates.
And one other caution I think we should make sure listeners are aware of, and that is when you're blowing insulation into your attic, you have to be careful about not covering up soffit vents and blocking your air movement from your soffit up to your ridge vent if that's the type of ventilation you have in your attic. You may have to add some baffles that allow that air to come up through. Does that make sense?
Yeah, absolutely. Ventilation is typically highly overstressed. In fact, I used the line from Bill Rose being on your show, I think back in 2009. He said that attic ventilation is the Britney Spears of building science. No newscast is complete without it, but it contains absolutely no substance. So that's perhaps a touch extreme, but if you're struggling with comfort problems in the summertime, air sealing is probably 80 or 90% of the equation, along with some insulation, and the rest is attic ventilation. So you want to have decent intake and decent exhaust ventilation, but typically it's beat on too hard. That said, if you are installing blown insulation in your attic, put baffles in. You're not going to be able to do it easily later. So just do it while you're doing it.
All right. Cliff, before we break for halftime, anything you wanted to ask or anything you'd like to add?
No, I just want to hear the Britney Spears quote again.
She stayed out of the news for a while, thankfully now.
Right. I'm good.
Good about that. All right. We're going to break for halftime. We'll be right back for the second half of our interview. We've got Nate Adams, the House Whisperer.
IAQ Radio Platinum sponsor is John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Gold sponsors are Particles Plus Engineers and Manufacturers of feature-rich particle counters and air quality monitoring instrumentation. Learn more at particlesplus.com. Count on us. Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at healthyindoors.com. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at AEMLinc.com. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com. Association sponsors are the Indoor Air Quality Association, a multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Learn more at IAQA.org. And RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org.
All right, we're back with the second half of our interview with Nate Adams, the House Whisperer. We're talking about the evolving world of home performance, and today we're focusing in part 3 on insulation. So we're going to go back to our little PowerPoint we have going along with this, and we'll also do a good job of describing things for those of you listening on the podcast. So the next one is just a little more on fiberglass rolls or bats. Nate, any comments on fiberglass rolls or bats and some of the key things with those?
Sure. So first, I'm going to make somebody angry and say generally in retrofit projects, you probably want to avoid fiberglass bats unless you are doing a very thorough job of air sealing first. Typically on older homes, I'm thinking, say pre-1940, which we do a fair amount of work on. They didn't have sheathing at that point. They were using 1x10s typically for exterior sheathing, and they had a 1/4 inch or a 1/2 inch gap in between them. Every one of those is an air leak. So if you don't seal every single one of those gaps, the fiberglass is not going to help you. So now you're wearing a sweater on that pier and it's blowing through it. So in a sealed cavity, fiberglass bats are great. But you want to be very, very cautious just slapping them up in a retrofit job.
Real quick, Nate, with that situation, you got the 1x10s with the gap. Is the dense pack going to be a better choice in that case?
Yes.
Dense pack cellulose.
Yeah, it's kind of funny. I've researched every different type of wall insulation out there for retrofit applications, and I've come back to dense pack cellulose every time.
Okay.
Keep thinking surely there's got to be something better than this technology that's been out there for 60 or 70 years. Nope, it's when you measure results of the blower door, it wins every time.
Well, we're going to talk about one that people claim is better in a little bit here for those that are interested and that may be thinking ahead a little bit. We'll talk about injection foam in a little bit, but first let's go to the next one, John. All right, so we're talking about foam now, and we've got foam board options up on the screen. For those of you listening on the podcast, we just have a picture of extruded polystyrene, expanded polystyrene, and polyisocyanate, sometimes referred to as polyiso. Expanded poly we'll call EPS. Extruded poly we'll call XPS. Nate, let's talk a little bit about these.
Sure. So all three of these can be very viable options. They all have different pros and cons. we end up preferring generally to use extruded polystyrene or XPS. That is blue, green, or pink, depending on your brand. It does not absorb very much moisture, so you can use it underneath slabs. It's easy to score and cut. You can, you score it and then you snap it like a piece of drywall, so it's pretty easy to play with. And it's really easy to find. Most lumber yards are going to have it. Every big box has it. You can get it in thicknesses from a 1/2 inch to 4 inch in general. Although those thicknesses are true of pretty much all the insulation types here. Expanded polystyrene, the easiest way to think of that is if you've used a styrofoam coffee cup, it's the same stuff. It's little white beads of styrofoam. And actually extruded polystyrene is the same thing, only it's extruded so it gets pulled. So those round pieces are no longer round, they're very long, and they all become one piece. But expanded polystyrene tends to absorb moisture a little bit more, and its R value per inch is a little bit less. If memory serves, I think it's like 4 per inch, where extruded polystyrene is 5. And then the last type is polyisocyanurate, which is quite a mouthful. And that is basically closed cell spray foam sandwiched between 2 pieces of foil. And you can get that in different thicknesses. And then that's used in a lot of other products too, if you're talking new construction. Zip-R sheathing, it uses that. And then, shoot, I can't think of it, the big pieces of wood with the foam in between them. My mind's blanking at the moment. I can picture them fitting together. You get like 4x8 sheets that are 3, 4, 6 inches thick with OSB on either side, and that's also polyiso foam in the middle. It's closed cell foam. Polyiso will absorb water, so you don't want to put it below grade. And when you give it extreme temperature differences, its R value has been found to degrade, even though it's rated an R7. So there's pluses and minuses. You can drive yourself crazy trying to decide which one of these you're going to use. As long as you are above grade, you're going to be decent with any of them.
And the XPS can be used below grade as well.
Yes, yes.
Okay, which is a really nice thing to have when you're. My son's working on a home right now where they use that below grade, and it's probably the only thing that saved this foundation from rotting away. It's a wood foundation. It's the first one I've run into, and they have 2 layers of 2-inch XPS on the exterior of it. It wasn't flashed as well as it should have been, but I think it saved this home. You mentioned using it underneath slabs. The other area we see it being used a lot more nowadays is as a covering over the exterior of homes. Where they're putting XPS because it seals very well and it becomes a really nice air seal when you tape the joints. Can you talk a little bit about the pros and cons on that?
So that's going a little bit outside of my strengths as far as expertise go. But what is good about wrapping insulation around the entire outside of a building is your average R values go up a lot. You reduce thermal bridging. So if you think about a typical wall, 16-inch on center construction, you've got a stud anywhere between 10 and 20% of the total wall area. And so that stud's only going to have an R value of 3 or 4, and you can see that in infrared work. Now, as soon as you put foam board on the outside of that, instead of having the R3, say you use an inch of XPS, you've got an extra R5. Now you're a minimum R value of R8 up from R3. So it can be really useful for that. One product that the builder that we work with has been using, I mentioned it earlier, is Zip-R, which is zip sheathing that has polyiso foam board sandwiched in it. And the stuff seems to be pretty remarkable. The blower door numbers that this builder is putting up are amazing. The most recent one, I don't think he's quite going to hit the passive house tightness level, but he's going to be close. So passive house looks for air changes per hour at 50 pascals, which is a whole other metric that we probably shouldn't get into. But they're looking for 0.6, and this house tested at a 0.8. And this is using very traditional building materials, nothing exotic. So I was amazed that he got that far, and the Zip-R sheathing was a big piece of that. So that's what you were talking about. It's a sandwich of OSB and insulation.
The problem with retrofitting with that technique, but by putting an XPS on the exteriors, you've got windows, you've got you got trim, you've got all these things you have to work around. Even when you're taking off siding and recladding, it might add 2 inches to your profile there, and that can change a lot of things.
Yeah, you're going to have to buck windows and do a bunch of other things. So in a retrofit job, you're generally not going to do that. Typically, when you get into that, you're talking $50,000 minimum just for walls.
Mm-hmm.
And that's typically larger than the budgets of the projects that we do for just one piece of the project. So wall insulation in retrofits is not as important as people think that it is. It's usually the last thing that we do priority-wise.
Okay, let's go to the next slide, John. So we've got other options here, Nate. Rock wool, denim, straw bale. I mean, you hear about all these wonderful green insulations out there now. They're cutting blue jeans up into shreds and putting them in walls. Let's talk first a little bit about rock wool.
So rock wool is largely a commercial product. So those are used in firewalls, lots of different breaks and so forth. So it's a very fire resistant material. So if you need to insulate up against a chimney, that's the kind of material you're going to want to use. In general, it's not something that you're probably going to use that much in retrofit. You can if you want. It's a batt material. So again, it has the drawbacks of using batts that fiberglass does. So it's not something we use that often in our projects. On the other hand, the other materials you mentioned, denim, straw bale, wool, the curse of those is they're difficult to source. And so you will probably end up spending a ton of time and effort trying to source them and get them and install them well, where if you had gone with more traditional materials, the same amount of effort likely would deliver better results. So we tend to steer away from those. We like to stick to commonly available, commonly installed materials.
Go to the next one here, John. So we hear a lot these days about closed cell spray foam, open cell spray foam. You've got, I think most people are familiar with single component spray foam where you get a can of great stuff at Lowe's or whatever and spray that on. Let's talk a little bit about the pros and cons of first closed cell spray foam.
Okay. The biggest con of closed cell is that it's expensive.
Yeah.
This is hands down the most expensive common insulation material. The pros of it are this gives you control of air, heat, and moisture flows simultaneously in one product at one time. It's relatively easy to install well. It's fairly easy to quality control the job, and it's quite easy to deliver nice results. So we end up using a great deal of this. It is basically impervious to moisture, which is really nice. And the air sealing job that it does is basically second to none. We use a lot of this on our projects.
And what about the R value on this one?
This is either R6 or R7 per inch, depending on the manufacturer that you're looking at. So it's the highest R value by a large margin. But again, R value has limited functionality. So you get 3 or 4 inches of closed cell in most climates. That's going to be adequate. That's not going to be code, but for retrofit projects, you'll be surprised at the results you can get from that.
Okay. What about the issues that people have with indoor air quality when closed cell has been used? Not only indoor air quality, but there are fire issues as well. So, none of these products has zero cons. They all have some pros and some cons. Let's talk a little bit about your experience with closed cell when it comes to indoor air quality, how we avoid those issues, and let's just start with the indoor air quality.
Okay. So actually, let's flip to the next slide.
Okay.
Easiest way to do it. We monitor air quality. Energy Smart has more FUBOT air quality monitors deployed than probably any other single company in the country. Despite the fact we don't have a huge number of projects, we have anywhere between 1 and 4 of these in almost every project that we've done. And so closed cell, yes, it is not very nice from a chemical perspective. So you need to leave the house during spray And for at least 24 hours afterwards, preferably 48, and you need to ventilate the house. So whatever you're going to do, get some air into the house and change the air as much as you can. Which means generally it's better to do this in warmer weather because you can leave the house open after the job. But this chart that we're looking at here, this is the VOC chart from a FUBOT, VOC, volatile organic compounds or chemical pollutants. It picks up some of the chemicals in closed cell spray foam. Don't know which ones for sure, but it picks up some of them. This project here, we did almost exactly 2 years ago. So the weather was turning on us. It was the end of November, and the client was out of town. So we did the spray foam job, and I left the house closed up. And then we got to watch how long it took the chemical pollutant levels to degrade in the house when it was closed up. And it's almost exactly 2 weeks. So it was 13 days to degrade back to original levels. So ventilating after a spray foam job is utterly critical. Really needs to be dealt with.
Now, did you ventilate here and it still took 2 weeks?
No, we did not ventilate. So this is, I just closed the house up and left.
Gotcha.
Normally we wouldn't do, but he was gone for 2 months, so it didn't matter.
Okay.
He thought it was interesting too. This second slide, this is another project looking out over a week, or so actually a month of FUBOT data, and there's 2 different FUBOTs here. The blue one on the chart here is in their bedroom, and if you note, every day there's a fairly substantial spike. That spike is from the VOC sensor picking up carbon dioxide. That picks up chemicals, carbon dioxide, and carbon monoxide. And the only way to figure out what it is to be a detective, understand where it is, what time the spikes were. But if you take a look at the spikes, I've got this notated as to when the job was. We were ventilating heavily on this, so while it was spraying, we had the blower door blowing into the house pretty full force. And at nights, this was on the 3rd floor of a 1928 house, something like that. We had the windows open and box fans in, blowing air through the space. So the spike of VOCs was no higher than it was on normal days. So we stayed in the 400, or what is it, 486 was the highest that we saw, where in the last slide we were getting up to 1,000 parts per billion. Not that these sensors are hyper accurate, I don't want to act like they are, but they give you an idea. And
gives you one of these, a little rough idea.
Yeah, exactly. Think low, medium, high. That's what these sensors are really good for. But the key here is if you're going to use closed cell spray foam, you need to ventilate, and it takes about 2 weeks for levels to fall back to normal. So you want to leave windows cracked or whatever's necessary to move the air through the house.
Okay, let's go to the next slide, John. I got a text question too, Nate, that I want to ask you, but it kind of fell in right here. I'm not sure. He asked if Nate is using a process called air seal. I'm thinking maybe that's aircrete.
Oh yeah, he might be thinking of aircrete. So aircrete, so we're on the injection foam here. So aircrete is a form of injection foam, but it's not the kind that I'm thinking of. Aircrete is a cementitious foam. It's actually a really, really, really lightweight concrete is what it is. It's supposed to have minimal shrinkage rate. My partner has it in his house. The blower door number on his house is at least decent, but we don't know for sure whether it has shrunk and opened up the leakage in the house again or not, because it's difficult to tell because my partner was doing multiple things to his house at the same time. So of the injection foams, aircrete is probably the best one. But your traditional injection foams, which used to be known as that was urea formaldehyde foam is what they used to be. They've basically been resurrected. And this stuff shrinks like crazy. So every other insulation type, in my eyes, has a place on the market. It has a use. It may not be something you use every time, but there's a place for it. It should be on the market. Injection foam, it shrinks horribly. So this is the picture on the left here is in my house. We took a piece of the siding off, and it had injection foam put in. It shrank horribly. It's about 3/4 of an inch, well, anywhere between a 1/2 inch and 1 inch on either side of the stud. So there's no air sealing coming from this product anymore. And to get it out, you're going to have to remove a lot of siding. It's a lot of work to get this back out. This is not something you just fix easily. I can't go and dense pack it again with cellulose. This house has been screwed up. Meanwhile, the picture on the right is the kind of workmanship that's, I don't want to say this is always what you're going to get, but you can. In fact, the same thing could happen with dense pack cellulose if somebody's not paying attention. But there's a picture where only the top of the wall has foam in it. It's like the top foot, and then there's some old fiberglass right below it. And you can see, even from 20 feet back, that it's shrunk quite a bit around the edges.
Mm-hmm.
This is not a good product. So I put a challenge out in 2012 when I got really mad about finding this in my house. I put a challenge out for any of the manufacturers or any contractors to come in and show me before and after blower door numbers, and then also 5 years after what the blower door number is on the house, and show me that it's effective. 6 years later, nobody showed up.
Haven't seen anything. And I understand that some people sell this as having the capability of kind of working around that fiberglass.
It could, if you did it with care, but so can cellulose. So blown fiberglass or blown cellulose in the hands of a good installer. If you have R11 in the wall, that's fairly thick. The insulation is pretty dense, so it's hard to get more in. But if you have old school R6 or R8 in the wall, you can almost always get more insulation in there. You just have to be patient.
Okay, let's go to the next one, John. And what about air quality? So we're talking about tightening up, air sealing, adding insulation. We just want to make sure that when people do that, we keep indoor air quality in mind. Nate?
Exactly. So when you're tightening a house, you were leaning somewhat on natural ventilation before, and now you don't have that anymore. The good news is you can bring air in from one known source. So it's not going to be air leaking in through really yummy places like inside the walls or in the attic where you're breathing mouse poop or mouse pee or who knows what. There's a lot of unhealthiness that you're going to be breathing in a leaky house. But as the house gets tight, you do need to deal with providing fresh air. So the house doesn't need to breathe, but the people do. So if you are adding fresh air to the house, you're filtering it well, typically by running an air handler all the time. Be careful if you live down south, that's a dangerous recommendation. But if you're up north like I am, where the ducts are inside the house, running the fan all the time with a good filter can be helpful. And then you want to have good dehumidification capabilities all the time. That's what we were talking about at the Healthy Building Summit. I think there's all kinds of moisture issues coming our way. So every house should have dedicated dehumidification. And then the last piece of it is monitor what's going on in your house. Get an air quality monitor, get a temperature and humidity monitor, and make sure that your levels are not getting out of hand.
Let's go to one more, John. Okay, we were talking about your presentation. It was called The Coming Mold Explosion. And it just so happened after I got back from our Healthy Building Summit last week, I saw this article. She bought a new air conditioning system, and now her house is filled with mildew. I sent it over to you, and I'm just wondering if this kind of falls along the lines with what you were talking about, that as we build new homes and as we change out old mechanical systems for newer, more efficient ones, we're losing some of the latent capacity and not really drying things out. And that's why you mentioned on the last slide, we should probably always look at having dedicated dehumidification in homes. What do you think on this, Nate? Do you think maybe this article was planted just so that we could talk about it this week?
I think that's exactly what the Washington Post was trying to do. So yeah, there's going to be these guys near Pittsburgh having a conference. I think we should write this article for them.
Why not? So yeah, I think maybe you could just quickly mention for listeners why you think there is a coming mold explosion.
Sure. Let's flip to the next slide for that.
Go ahead.
This is a slide from the presentation. So what I'm seeing and my brethren in the home performance industry are seeing are a bunch of things that are leading to mold calls unlike we've ever seen. So typically my industry doesn't get a ton of mold calls. It may be moisture, but it's usually rot more so than mold. Everybody has said that the number of calls they're getting to fix mold are at least double over where they've ever seen them before. And what we're thinking is there's a bunch of different tipping points that are all happening at the same time. And any one of these factors can tip a house from where it's healthy and dry to where it's unhealthy, wet, and potentially moldy. So dew points this year, which is the amount of moisture in the air, the dew points on the East Coast have been insane, like up 5, 10, 15 degrees over where they usually are. So now a house that you leave open in the summer that used to be okay because the surfaces didn't get below dew point, where like in the basement, you're going to have, surfaces that are going to be in the 60s pretty much all year. Now the dew point's getting high enough that it's getting wet in places that it never got wet before. And when you have moisture plus food plus the right temperature, you're going to get mold somewhere, depending on the species. So the dew points being up are really problematic. Heavy downpours are up substantially across the country, anywhere between 10 and 50%. So when you get a huge rain, it's going to stress your foundation, and you're more likely to get water to come in. So that's more moisture load. Modern dehumidification or modern air conditioners tend to sacrifice humidity removal for heat removal. So if you have an oversized air conditioner, it needs to run for about 10 minutes before it gets the coil inside of it cold enough to start doing dehumidification. And it may not be that great at dehumidification anyway, but if it's oversized, it may not run for that 10 minutes to even get cold enough. So you end up not dehumidifying at all. And that is probably exactly what happened to that lady in the last picture. And I saw another project exactly like this down in North Carolina with my own eyes. That's actually what generated this whole thing. It just made me start thinking about it. The other couple pieces are engineered building materials like we use today with lots of man-made materials in them. Most of the materials in them are mold food, like drywall in particular. Paper is mold food, and that's on the front and back of every piece of drywall. And then trees are getting bigger. So every year there's more shading on houses, and the more shade there is, the less the sun can hit the house and dry it out. So all 5 of those, dew points, heavy downpours, HVAC dehumidification being down, modern building materials, and increased shading, any one of those factors can tip a house to being unhealthy. And we're seeing just a ton of houses tip right now. Okay.
Next one, real quick, is at the last slide. So summarize it for us, Nate.
Sure. Well, it's what we've been talking about the whole time, and the whole book is all about getting control here. So controlling air, heat, and moisture. But there's another slide after this too, a couple more actually.
John? I got the home comfort book right here. I love it. Oh, avoiding the gulf of disappointment. Yep.
Well, and we're over time too, so whatever we need to do.
Well, let's just touch on that. I'll tell you what we'd like to do. I think if we can just talk a little bit about the project design and then wrap things up from there. And then Cliff has a little something he wants to show from his recent trip to the ISSA conference. Very interesting.
Awesome. So what we end up doing in our practice, we are trying to create projects that have a high likelihood of success. So we have to find a way to match up 3 different things somehow. So on the screen is a Venn diagram, and the 3 circles are goals, what you want to fix, house needs, you have to diagnose the house and see what the problems are, and budget. If you can't somehow get goals, house needs, and budget to cross, you don't have a viable project. So everything we do leans towards figuring out what is that viable project? Does it exist? Does it make sense to do? Or should you just live with it and leave the money in the bank?
Gotcha. Fantastic. Thank you so much, Nate. We really appreciate it. You gonna stick around while Cliff goes over some of this real quick stuff? By the way, we've got up on the screen NateTheHouseWhisperer.com, and also that on there you'll get a link. You can find the home comfort book, also some case studies, very interesting case studies Nate has up on his website. Nate, anything else you'd like to add before we turn it over to Cliff?
Thank you for having me on again. It was good to be able to work through all of this.
Hey, I tell you, we did it in only a little over an hour. Not too bad, Nate. Cliff the Z-Man Zlotnick, just back from the ISSA. I guess that used to be the International Sanitary Supply Association.
Yeah, I don't think they've changed the name. I just think that, they've always tended to use the acronym. It truly is an international event. I mean, there were exhibitors there and attendees literally from all over the world. And there are a couple of trends that I just thought that I would mention. I think a couple of weeks ago, Joe, or it was at the HBS or whatever, you'd mentioned something about, why they couldn't have bigger robots. You'd have the little ones that kind of clean your living room. And, what was amazing is this year they had, some big ones that are capable of, washing and scrubbing and rinsing floors, without manpower. So that was one of the trends that I thought was pretty interesting. Another trend that I saw there was some changes in disinfectants and disinfectant application equipment. There seems to be a movement towards electrostatic equipment. It's kind of interesting because, electrostatic equipment can simultaneously spray both the front and the back of things. So for instance, if there's a picture on the wall, as long as there's an airspace, you're kind of spraying both the front and the back simultaneously. I think that's important, to be able to get in cracks and crevices in hospitals, nursing home, places like that where acquired infection is a big risk. I saw a really cool cleaning system for reaching high areas. There's a company from England, and they had this vacuum system with brushes, different types of brushes, that could swivel. But one of the cool things about the system was it had a little camera, and you could actually see what you were cleaning, and these systems can be used up to about 50 feet. Very, very lightweight, some pretty slick stuff. I know, over the years in restoration, I've either consulted or done a number of large projects in factories where these things just would have saved an incredible amount of manpower. There's Richard Shaughnessy, Dr. Richard Shaughnessy, our guest. I attended a program that he did on green cleaning in conjunction with the EPA, and he talked a lot about ATP and taking the initial ATP study that he was involved with the K-12 study and taking it a little bit further. And they're looking at things, and he's working with Dr. Jordan Pesha, who we had at the Healthy Building Summit. Okay. And some, work on DNA and so on and so forth. So he did a really good job. Really, really well attended program, and everyone there was running a school. I think one of the highlights for me actually was being about 100 feet away from George W. Bush, 43rd president, and it was really, really cool. There was a packed room. There were probably 6,000 or 8,000 people in there witnessing it, and they called it a fireside chat. He was interviewed by a fellow by name John Barrett, who's the current, executive director of the ISSA. And I found him to be, I think everyone there was surprised. I think we all found him to be sincere. We all found him to be funny, his self-effacing, he kind of laughs at himself, and it was really, really good. And some of the things that were touching, things you never think about. And I think one of the things that he talked about was when he was president, it was really hardest on his kids. When he was either running for office at different points of his life or in office. And, when the press gets nasty and the television gets nasty, you have young children and they kind of watch television. They think everyone hates their father and stuff. That, and it was I found that really, really touching. Another thing that he said was kind of unique is I never realized he was always a big history buff and always read a lot about history, and he just talked about how unique it was to be in the White House reading history and making history at the same time. And, he also talked about some of the words that he would tend to make up. And I wrote one down, misunderestimate. And to me, that was, that was good. But I just want to thank Jeff Cross with CleanFacts Magazine and the ISSA, and Chris Munchak with BSCAI for inviting us to come down and get a press pass and be able to take some pictures and see what was going on. But I thoroughly enjoyed it. Hadn't been there in a long time. It was good.
Well, great. And thanks for the update. That's excellent information. We're going to wrap it up here. I want to say thanks to Nate, the House Whisperer Adams, for joining us today. Get a chance, get a copy of the Home Comfort book. I got my copy here. Easy to read. Great stuff in there, Nate. Again, thanks for joining us. I think you did a great job, and we got the 3-part series now. It'll be up. It's archived, and folks, I definitely would encourage you to listen to parts 1 and 2 if you haven't heard them. We'll be back next Friday. I want to thank my co-host, the Z-Man, Cliff Zlotnick. Of course, today's guest, Nate Adams. John, you got to have faith at the controls. Most importantly, our growing group of loyal listeners. Check us out on YouTube or on the podcast, Podbean. We have the shows up there, and please send us a note sometime or give us a like on Facebook. We got our IAQ Radio Facebook page. We'll be back next Friday at noon for the next broadcast of IAQ Radio.
For IAQ Radio, I'm Spike Reed saying thanks for listening.